You know how your music playlist just magically knows what song is next, or how your browser's back button works so well? Well, a lot of the time, the secret sauce behind that is a data structure called a linked list. Today, we're going to pull back the curtain and see exactly how they work with some really clear, practical code.
We're going to start from the very beginning, building a list from scratch. Then we'll see how to remove things, check if something's in the list, find out how big it is, and finally, how to get in there and change stuff. Let's get to it.
Okay, first things first. Before we can do anything cool, we have to actually create a list and put some data into it. This is the foundation for everything else we're about to do.
So that first line of code, that's us creating a brand new empty linked list. We have to tell it what kind of data it's going to hold. In this case, it's a string. Then to pop our first element in, we just use the super simple .add method. That's it. It tacks our new value right onto the end of the list.
And here's what that looks like in the real world. We've made a list called list1, and we're using that .add method 4 times. See how each name just gets added to the end? It's like we're building a chain, one link at a time.
So after running that bit of code, what's the result? Well, the list now holds our 4 names, and if we print it out, we see them in the exact order we added them. Manusha, then Kalam, Nethmi, and Maheshi at the end. Perfect!
But what if you don't want to just add to the end? You've got options. addFirst is great for putting something right at the front of the line. And for total control, you can give it an index to stick an element exactly where you want it in the middle of the chain. Okay, let's look at the absolute simplest case. We make a new list, LList, and we add just 2 things, B and then C. So when we go to print it, what do you think we're going to see?
And yep, there it is. The output shows a list with B followed by C. It works just like you'd expect. Simple as that.
All right, so we know how to build a list up. Now let's talk about how to take things away. Because managing data isn't just about adding new stuff, right? It's also about getting rid of what you don't need anymore.
Java gives you a few different tools for this. You can pinpoint a specific item by its position using removeIndex, or you can just chop off the ends of the list really easily with removeFirst and removeLast.
This piece of code shows our removal tools ready for action. They're commented out for now, but just imagine if we uncommented that Lil's list.removeFirst line. Our list, which was BC, would instantly become just C before it gets printed. It just shows you how easy it is to change the list structure on the fly.
Okay, this is something you're going to need to do all the time. You've got a list, and you need to quickly find out if a certain piece of data is actually in there without having to look through it yourself. I mean, sure, you could write a loop to go through every single item one by one, but that's slow and kind of clunky. Thankfully, there's a much better way. Linked lists have a built-in method just for this.
And that answer is the .contains method. It's so beautifully simple. You just ask it, hey, does this list contain this value? And it gives you back a straight answer. True if it's there, false if it's not.
So in this example, the code is using .contains to ask our list if it has the letter G inside. That true or false answer gets saved, and then a little if-else statement gets ready to tell us the result.
And no surprise here, our list only has B and C in it, so the search for G turns up empty. The .contains method returns false, and our code correctly tells us, nope, that element isn't here.
All right, let's look at something that's super quick, but also super essential. Just checking how many items you currently have in your list.
It honestly doesn't get any easier than this. You just call the .size method, and it gives you back one number, the count of elements in the list. This is so important for things like loops, where you need to know when to stop.
Okay, last but not least, let's see how you can reach into the list, grab a specific item, or even change it to something totally new. This is how you really interact with the data you've already stored.
So, over on the left, you've got the tools. .get to fetch an item by its number, and .set to update an item at a certain spot with a new value. And then on the right, you can see them in action in a real exercise. Let's just follow the logic here. First, the code uses .get3 to see what's at index number 3. Then it immediately uses .set3, J, to swap out whatever was there with the new letter J. If you printed the list right after, you'd see that change instantly.
So what's the big takeaway here? It's that with just a handful of these core methods, add, remove, contains, size, get, and set, you've got a complete toolkit. It gives you this incredibly powerful and flexible way to manage ordered collections of data. That's what makes the linked list such a workhorse in programming.
So, there you have it. You've just learned the fundamental building blocks for one of the most essential data structures out there. You have the tools now to start organizing data in all sorts of new ways. So the only real question left is, what are you going to build first?